Question 52 says, what is the slope of this line? Some different ways to think about slope. Slope can be considered as rise over run, or you can think of it as the change in x values. Let me rephrase that. The change in y values over the change in x values. These are the two most convenient ways to think about slope. If you have a graph, I prefer this way personally. Rise over run. So if you have the graph here, you're looking how far does it go up, that's the rise part, and then how far do you go over, that's the run part. Personally, I like to always go left to right. That just seems to make it easier for me. So my rise part, I'm going up 3. If I was going, this was a negatively sloped line, I'd be going down a certain value, but this is going up 3, and then it's going to the right 4. So my rise would be 3, and my run would be 4. If I used this method instead, so let's write down those coordinate points. -2 is my first coordinate point, and 2, 1 is my second coordinate point. If I labeled those as x1, y1, and x2, y2, hopefully that makes sense. That's your first x and y coordinate and your second x and y coordinate. And then just use this formula right here. It's your change in y's, which hopefully makes sense. That's the rise part, that's the up and down part. And then the change in x's is your run part, that's the left or right part. So if I take that and just plug in the numbers into this, I'm going to use y2 I labeled as 1. So I've got 1 minus y1 is -2. The form is y2 minus y1, so you have to do 1 minus -2. And then on the bottom I'm going to have 2 for my x2, and then x1 is -2 again, minus a -2. So make sure you're putting those negatives in parentheses especially. This becomes 1 plus 2. 2 negatives will make a positive. And this would become 2 plus 2 on the bottom. And so you'd get the same answer, just like we should have expected. We get 3 over 4. So the final answer, using either method, same answer, 3 over 4.